Hello everyone, December 27th. Alright, finally we have a hard question. Been like doing easy and for a very long time. But this one has 50% passing rate, so it's probably not one of the real hard ones. Run length encoding is a string compression method that works by replacing consecutive identical characters with the concatenation of the character and the number marking the count of the character. For example, this will be A2B C3. Makes sense. We're not adding 1. Makes sense. If we're adding 1, we're actually not compressing, right? So anything that's, if it's 2, then we're not really compressing. It's the same cost, but anything more than 2, we're compressing. Given an S and an integer K, you need to delete at most K characters from S such that the run length encoded version of S has minimum length. Find the minimum length of the run length encoded version of S after deleting at most K characters. So we can delete at most K characters. Okay. K characters. And, well, if you delete the single ones, then you're definitely reducing its size, right? If you delete single ones, you're definitely reducing its size. If you delete the multiple ones, if they are not around the edge, right, between like 2 digits and a 1 digit, right? If you have something that repeated 10 times, then you delete 1, then it will become 9, it become a single digit, right? So you also can reduce. So what we want to do is delete at most K characters. To reduce, I mean, you delete at most K characters, you might as well just delete all of them, right? Because if you have 2, if you delete it, then you'll also reduce it. So you might just basically just delete K. Okay, you delete K, and the question is, what is the smallest length? Maybe we should just, as a start, write out the string compression first. So in the first one will be A3, B, C3, D, right? And then looking through this, and then K is equal to 2. Okay, K is equal to 2. The rule of thumb, right? Rule of thumb is if you have, I'm not 100% sure, but I feel like if you have individuals, you just definitely remove them, because each one you remove, it will be the same benefit, right? Because you remove a letter and you try to make the string compressed version, you want to make it shorter, and the maximum you can reduce by remove a letter is reducing the length by 1, the maximum. Therefore, if you remove, and by the way, is to delete K characters and then perform, which means if we have something like, yes, I was going to say, this is going to be A4, right? Very interesting. Okay, we might have to DP this thing, I feel like, because you have these kind of situations. So let's say we DP it, right? We have, A, B, B, A, and K is equal to 2, so we can remove 2. So maybe we can say, I don't know, S DPI. Okay. Maybe DPI K. Because you want to know the state, right? Which means add a certain and delete how many. Okay, so maybe I can do this. dpij is, let's say, the minimum length of run length encoded version of S. The minimum length of encoded version of S ending at Si with J number of letters deleted. How about that? How about that? With J number of letters deleted. Okay? With J number of letters deleted. So, if we have dpij for everybody, right? Now we are looking for a new one. Right now let's say we handled, now this is a new one. So we want to compute dpi plus 1, right? Whatever, j. Oh, how do we do that? Well, we're considering the new one here. Then, we have all the previous, right? We know all the previous. So for this new one, we can always say, do we delete it, right? Or do we not delete it? That's the two choices that we have for the new one. And if we do not delete it, okay, we do not delete it. Ooh, if we do not delete it, it depends on what's the minimum length. It depends on the previous, right? It depends on the previous, what the previous is gonna look like. Now the previous, don't we also need to know what the previous look like? Right? We need to know what the previous look like. Maybe it's not the minimum length. Maybe the dp value is the actual string. What do you think about that? The actual string. Because I need to know what does the string look like, and then that will. So let's say we know the string, the minimum length of the string, okay? And so the minimum length. But what if we have multiple strings of the same length? Yeah, what if we have multiple strings of the same length? Yeah, I'm thinking is like for this current A, I don't delete it. Then we look at dp, the previous one, start with j, from 0 all the way to k, right? From 0 all the way to k. And each one, if I have the minimum length, which is not enough, but we can't really do it that way. We need to know the ending, right? What is the end? Or the ending is, what is the end of the previous one? Okay. So let's say the end is, that's still not gonna work, because if the end is A and now is A, how do you know what it's going to be? What are you thinking? I'm thinking about, I don't think that's gonna work, because K is, there's so many ways to remove. What you saying? Like DP, the substring and the remaining. So what is the, so maybe we can call, DP, substring, and remaining. The minimum length of doing this. Okay? Then when we have a substring, then we just go through every single one, and then we just remove one of them, do the rest. Then it's the count of substring. That's huge. That can be huge. You know? Or we don't do the substring, we do the string compressed version. We do the string compressed version as we do A2, B2, and A2, right? And then we have these positions. Like, we have A, B, A. Right? We have these positions, and each one is associated with a value. And then we say, well, if the length is smaller than k, then the answer is 0, right? And then length is smaller or equal to k, the answer is 0. So when we move on to this position, okay? So we want to know what is the smallest. Wow, that's pretty hard. Or maybe it is. We find out the minimum sizes of all of them. Maybe we can return to that idea, right? For each one coming in, and if we can remove, if we cannot remove, then if we the number of remove, we remove everybody already. I mean, no. We go through, like, nothing is removed, and we check what is the previous, and then the current, nothing is removed, we have it. If we previously removed one, and we find the minimum, that's the thing. That's the thing. If the previous, if I remove one, it might have a giant list, right, of different substrings that would want to remove. And is a best in the previous always lead to the best right now? I don't know. I don't think so, honestly. Like, if I say I remove one, given a substring, what is the smallest removing one, right? What is the smallest removing one? And I say, if I don't remove myself, then I check the smallest of the previous. If I have a smallest of the previous, and then adding me, will that give me the smallest? Not necessarily, right? Not necessarily. If I remove myself, right, then it is the best. But like AABB, right? AABB remove 2. You have different way to remove 2, will always become 2. And it will have all different results. But only one of them will give you the best outcome. And you don't know which one. So yeah, that doesn't sound right. All right, I actually have no idea. It is DP. Okay, so what's the state? Okay, the current index and the remaining character to delete. I was thinking about that, but it doesn't really help. All right, let's go top down. Okay, maybe bottom up is a little bit hard to reason. Okay, so if we go top down, we say DP index, okay, and the remaining to remove. Basically, this one will say the minimum length, right, from S index towards the end, with remaining to remove. Okay, so we're asking what's dp0k, right? We're asking what's dp0k. So now we're looking at index again, right? Again, so we're looking at index. This one is looking at. And then we can say, well, keep it or we don't keep it, right? If we delete it, then the answer is just dp index plus 1, remaining minus 1. That's actually easy, right? If we delete this, then what is the remaining? Because I deleted, right? And the length, because I remove my current one, and the length shall just equal to this, because I remove the current one. If I don't delete it, okay, if I don't delete, so this one remains, then we have dp index plus 1 and remain. So we don't really, so that's is from this towards the end, but we find the smallest. See, that's the thing. I don't think this is right. I don't think this is right. We find the smallest from this towards the end, and then concatenate with the previous. How is this going to be correct? But we keep the current. It depends on what depends on what it starts with, right? Because this might be able to merge with them. That's my confusion. That is my confusion. Right? If you go, A, B, B, A, right? I say, if I delete A, then we do A, B, B, A. We do this with 1 remaining. If I delete this, then it's going to be B, B, A. That's the result. And then we can, compute whatever it's going to be. That is the result. Right? If I keep this A, then we are looking for, again, this with 2 to remove. If I keep this A, now we do this with 2 to remove. Right? You can delete this, and this is the remaining. So are you telling me that we need to return the actual thing? What do I return? The return minimum length is not going to work, because if the current one is not removed, I need to know what the return value is going to be. And what is this return value? Return the smallest, but the smallest might not be a better option. Hold that thought. The smallest, will the smallest be the better option? The thing is, if we have multiple smallest, right? Like if the current is A and then with returns BC, the ABC takes 3. But if I have another one, the return will be like AC. And AC is the same. Another good example, BCD, right? AAC. All right, the AAC wins. All right, yeah, that's we stuck on the same thing. Let's see the last hint. Having a prefix sum for each character can help you determine for a certain character C in some specific range, how many characters you need to delete to merge all occurrences of C in that range. Have a prefix sum for each character. The occurrences, right? Okay. Help you know how many characters you need to delete to merge all occurrences of C in that range. For a certain character in some specific range, how many characters you need to delete to merge all occurrences C in that range. Why do we think about it this way? Because each time you delete, right, you're reducing or not, you know, and each time you merge, you're also reducing, right? Because the action of merging is always no worse. The action of merging is always no worse than not merging. So you will try to merge. So the strategy is to remove such that you can merge. Because remove is reducing. Remove is not always reducing, but remove is no worse, right? So remove is always doing something good. And merge is also doing something good. So can we say, this is a kind of a little bit greedy, right? Can we say that the best strategy will be to remove such that we can merge things together? Okay. So now give me a string, right, starting from some index with how many to remove. Or again, if I remove myself, then I'm just gone. I'm just gone. And I want to find the remaining. Alright, which is, doesn't really matter. What is tricky is I don't want to delete my current self, the current index. Right? If I don't want to delete the current index, then for the remaining, we need to try to merge. Maybe that's the idea. If I don't delete the current one, then I need to find out how I can merge Like how many characters I need to delete starting from the next one in order for me to merge with myself again. Is that right? How many I need to merge with myself? I'm starting with the current one, and I say, figure out a way to count how many characters in between me and the next version of me. And if I can delete all of them, then I have a merge. Right? Then I have a merge. And with this merge, doesn't make sense. All right, let's check. All right, that's that. Okay, the minimum encoding length from index and with remaining number. Okay. What's encoding length? Give me a repeat. Okay. Yeah, that's fine. Impossible case. Okay. If len this minus smaller equal to, we can remove all the letters. That is true. That is true. As remaining, we can remove everything. Okay. And then I have a counter, max count. From this towards the end, I count everyone. Okay. Max count. Okay. A number of letters to remove in the number of letters to remove in S index to I, such that we have max count repeats of a single letter. What? What is this? What the hell is R? R equal to I minus index plus 1 minus max count. So we are counting from index to the end, and every time we count, we find that at the current moment which one has the max count. Okay. And then what we say is the max count will give us a, so R is the amount we want to remove. Right, R is the amount we want to remove. I minus index plus 1 as the total number of letters in between index and I. Okay, so total amount of letters, and I find the maximum amount, and we are removing everybody else. And once we remove everybody else, then we have the max count. Right? We have the max count. We have the max count. So what we're trying to do is to maintain the max count as we go through. If we maintain the max count, we'll remove R, and we'll do I plus 1. What? What? Oh, I plus 1. Okay. I plus 1 makes sense. I like the index doesn't make sense. Okay, I plus 1 makes sense. So basically, we're saying we're starting from index, right? As we move forward up until I, right? Up until I. And then from index to I, we say we're going to remove however much we're going to remove. And after we remove them, right, and then we have the max count, right? So after remove these things, the remaining will all have the same. The remaining have the same count as the same letter, and then they can be, combined, and then we do the remaining. So, okay, so can we say, wait, why is this one correct? Why is this one correct? Why every time we try to okay, so what we're trying to do is for each one we say the best we can do, right, from index to an I, the best we can do is always to condense the letter with the highest count. Why? Why do we say that, to condense the letter with the highest count? Well, the letter with the highest count, we can say if we don't do that, okay, let's just try to prove it by contradiction. If we don't do it, right, if we say we don't do it, then so we say someone has the highest count, okay? No matter what, someone has the highest count. The highest count can be 1, mind you. Someone has the highest count. Okay, someone has the highest count. And if we want to shrink this part to be the minimum, if we don't maintain the highest count, right, we delete something else. Then the highest count won't be able to merge. And maybe it does make sense, right? If you have a lot of the same and just a couple in between, you just want to remove those so you can, right, condense everybody. But still, why is that one correct? Alright, I have no clue why this is correct. Let's go to, let's copy this and how many repeats each letter gets in the final solution? build the first group. Hold on, I'm still not convinced. I read what I wrote. Lord, I read what I wrote in October 2022. But I still have no clue. Alright, let me think again. Alright, I think this one has to go from back front. Okay? Go from back front. So if we go from back front, let's say there gotta be an answer. Right? Some form of an answer. And that answer will have some letter repeated sometimes, some letter repeated sometimes. Doesn't matter, right? So we have just bunch of letters, not bunch of letters. Some letters repeated sometimes, some letters repeat sometimes. Some letters. That will be the answer, right? That will be the answer. But we don't know what this answer is. So what we're trying to do is to create all possible, try all possible ways, to find such groups, right? That's what the solution was talking about. The first group, we do not know what the first group is. We have no idea what the first group is. It's just some letter repeated sometimes. That's the first group, right? Some letter repeated sometimes. So we just start to build this first group. And the way we build the first group is find the max count. Yeah, find the max count, because the max, it doesn't really matter as max count. It's just one way to do it, because the first group in the final answer can be 1 letter, 2 letters, 3 letters, 4 letters. Who knows? Nobody knows, right? So if nobody knows how many repeats the first group is going to be, we might as well just try 1 letter, because we don't know which one it is. We just try 1 letter, because we start with 1, and we try 2 letters, we try 3 letters, 4 letters, all the way, and one of them got to be the answer. One of them got to be the answer, right? So we try to that, right? And then we basically complete the first group, and for the remaining we just do the same thing. Yeah, it doesn't really matter. Yeah, that's true. We just, it will be like the answer will be groups, right? Groups. And the first group must come from some substring starting from 0 to something. We don't know, right? And that just means we have some number of counts of the same letter, and then we need to remove everybody else, right? And once we've done that, we do the remaining. Can I upvote my own comment? I don't think so, but Lord. But I can respond to my well, Yeah, the final answer. The final answer is always going to be one group. Always going to be something, some letter repeated sometimes, another letter repeated sometimes, and our DP, right? Our task is to try from S0 to some Si such that we can encounter that first, so that we can not encounter, we can reproduce the first group, right? First group, so that we can produce the group of same letters that can lead to the first can always be divided into I don't know if this makes any sense. Divide it into chunks, with each chunk being some letter represented sometimes. Our task, the subproblem, right? The first subproblem is to find to go from this to some Si such that we can produce a group of the same letters that can lead to the first chunk. We don't really care what that letter is. All we care about is by removing certain number of letters, we can produce the desired group of the same letters. Once the first chunk is achieved, we move on, right, to produce the second chunk, which is a repeated, which is the same, right, the same subproblem starting from Si plus 1. Yep, great solution. Yeah. All right, hold on, need to feed my cat, but yeah, this one need to be brewed over. Yeah, I know. It's one of the problem, like, didn't really improve even after a year of practice. Thank you very much for playing with the cats. Nah, this is the IQ test. That's really IQ test. DP problem like that is really IQ test. I don't think there's any skills in this. It's just, I take it back. I think there is skill. This is one of the skill. It's to visualize what the answer is going to be, and Yeah, it's very important for this one in particular. You have to visualize what the answer is going to be, and starting from the answer, try to construct the solution, because you know what the answer is going to be, right? And then the question is, how do we manipulate? How do we create those, the DP, the subproblem, such that we can approximate, right? We can approximate, and again, DP is brute force, okay? DP is a smart way to brute force, and once we have the visualization, right? Once we have the visualization of what the final result is going to look like, then we can brute force it, right? We basically brute force to try to approximate, right? Try to approximate the final answer. And since we're brute forcing, we're trying every single state, every single possibility, and one of the possibilities will be the final answer. I wasn't using this. I wasn't thinking about the final solution. Yeah, I know my way is not going to be right, because I was thinking, okay, maybe I need to. Yeah, I know where I got stuck, because for each one, you just start thinking about, okay, if I delete this or if I don't delete it, it's kind of a very traditional way of thinking about DP, right? And then that's not gonna work, because delete is gonna work, but if you don't delete, you need to figure out, like, how is this one gonna merge with the rest, and that itself is insolvable. You cannot solve it that way. Has to think another way. I mean, yeah, this is actually it's an interesting question. Interesting question. Alright, cats. Just enjoy. Alright, you guys enjoy. I will try to implement this. It's not hard to implement. Of course, it's a hard question. We can always give us some slack. Hard problems, we can do. Oh, I never done one for. Okay. 20. Is it 28? Right. Yeah, it's 28.pi. All right. Did I not add this? Oh yeah, I add this. This is in my nightmare. Exactly. Nightmare problem. And I failed to solve it again. Just read the comments I made to understand the very, very brilliant solution. Oh. Two comments technically, right? So we go share. Two comments. All right, let's implement it. def encoded length, yeah. So L will return a int. So if L is equal to 1, return 1. If L is equal to 2, if L is smaller than 10, return 2. Right? If L is smaller than 100, return 3. Hola, if last return 4. Right, it's encoded length. Given the L, and then with all that, we know how length. Okay, so that's that, and that's on DP. Index remaining. We need to do this from func tools support LRU cache. Okay. We're gonna add LRU cache. All right. So, okay. Impossible cases first. If remaining is smaller than 0, okay. Math.inf. This is impossible case. Let's put some comments. Nothing to remove. Cannot remove anymore. I cannot remove anymore. Really? Yeah, cannot remove anymore. And we're trying to remove, but this cannot. So this is an impossible case. Okay. If len s minus index is small or equal to remaining. Okay, this is we can remove everything. Then I'll return 0. Okay, that's good. Next is try to go through all possible ways to form the first group in the final solution. All right, by removing all the letters from index to some I, such that the remaining letters are all the same, are all the same. Greetings. It's a pretty difficult problem. Couldn't solve it. Such that the remaining letters are all the same, but with different lengths. Okay, so like another way to say what we're trying to do. Okay, so for I in range, from index, do we do index plus 1? We say we want this range because index to index, maybe. That doesn't. Hold on, let me think. Do we do index or do we do index plus 1? Because I say is from index to the I, right? From index to I, we're trying to find what's the maximum of this. Then we'll remove it. Yeah, I think it should be from index all the way to len s, right? And we do need the max count. Yeah, max count is equal to 0. Okay. And the first thing we do is, we need to have the count. So we need a counter. Okay, counter is equal to counter. We didn't have counter. So in the collections, we need to import counter, right? And then we say counter is equal to counter. That's fine. And the first thing is counter si plus equal 1. And the max count is maximum max count and counter si. So yeah, the max count, the reason we do max count is because it must go from 1, 2, 3, 4, 5. That's why, right? And when we're trying to create the first group, we're trying to match to the first group that is correct. And we need to try, the first group is length 1, length 2, length 3. We have to try every one of them. So we have the max count. And we can say R, number to remove, okay, so equal to, from I minus index plus 1, total number of letters, right, from index to I, minus the max count. Okay, this is the total we can remove, such that the max count will be the remaining. Okay, so with that, right, with that, we can say, oh, I need the result for this math.inf, right? So with that, I can say res shall equal to minimum of res and something. What's that something? That something is encoded length max count, because that's when we remove everything. We have the max count remaining. So what is the length of the max count? That's the encoded length. It tells us plus dp I plus 1, because we have handled from index to I. We handled that, right? We get what is the max count is going to be, and then we have remaining minus to remove, right? So that's the result. So we go through blah 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 and eventually return result, and we'll return dp starting from 0 and with k. Oh, it was so good. This is such a good solution. My god. Let's hope the implementation is correct. When we just gonna go here, and then, oh, I put it Java. It's not Java. It's right. You are not signing. What the hell? I am signing in. Oh yeah, this thing is right. So this is the type of problem, you know, it's so hard that people can't solve it. That's what I think. It's so hard that you cannot solve it. So you just read the solution and then there's like 50% passing rate. It's not really. It doesn't represent anything. Index source NK, right? Oh, so good. Oh, so good. I'm pretty sure this is not what the official solution, because this hint really, I have no clue what this hint is trying to do. But this is pretty straightforward. Wow. Great. Great. Dear me. October. Yeah. Python DP. Oh, I upload this one as well. Yeah, I think the last time I went through a lot of different solutions is trying to figure out which one is makes more sense. That's why I upload this, which means it makes sense. And then is this one, which I really like, and I think I just stopped there. Oh yeah, the other one is 4D. Yep. All right, that will be it. I mean, we spent a long time dealing with this, but yeah, have a little bit more explanation this time. So hopefully in the next time when we hit this problem, it will take me less time to figure out how it works. I mean, man, I think if we do this one more time in a month, maybe I'll remember in a month, but this one will go somewhere here. I haven't even touched all these things yet. I already forgot. I already forgot. I think maybe sometime we should try these things again. Maximum queries. Oh, I remember this one. Oh. Oh, this is ugly. Yeah, maybe you should go back to try some of these again. Yeah, I should. Oh well, maybe we'll do that some other time. Anyway, that'll be it for today. I'll see you guys tomorrow. Adios.